solving radical equations. Solving, something you've been doing since back in junior high, grade 7. Actually started even looking at it in elementary, but unofficially. Well, we've solved different things this year. We solved quadratic equations last unit. Now we're solving radical equations. So equations, obviously, that have radicals in them. What's important with this is there's two key concepts. Algebra process. Same thing you've been doing, like I said, since grade 7. You have to manipulate, move things around because we need to isolate a variable. So that's the first step. And the second step is that idea of the square root principle. And we'll talk about that in a minute as to how that ties in with this. But square rooting a number doesn't mean you have one solution. It means it's going to possibly give you two. So if you take a look at page 13, the background points, I'm going to work not necessarily in the order that they're there, but the first thing is you need to identify the restrictions because we are dealing with radicals. Remember, a radical can have 0 or a positive number as the radicand. You cannot, in a radical, have a negative value. So we have to make sure that we identify values that will only keep the radicand 0 or positive. That's the first thing. The second thing is you always now have to verify. Before, you're always suggested to verify. But there are times that we will get solutions and we will find out, oh, x is equal to -3 or 7. But when you verify, it's possible that one of the answers doesn't actually work in the verification. That's called an extraneous answer. Maybe it's the 7. Maybe -3 is the only answer for that question. So 7's not allowed. It's referred to as extraneous. So we always have to verify our answers to make sure that what we have solved for does work. And now the third point. It's kind of quirky, but if you have some kind of a question where the radical is already drawn, if something ever said x equals square root, cube root of 25, in this case, x is 5. If the radical's already there. Now, what else could x be technically? X could be -5 because the square root of 25 is -5 times -5. But if you ever get a question where it starts off as the square root, we're only using what's called the principal square root or the positive. This is different than having a situation where we have x squared equals 25. Here, the square root, the radical, was already there. Here, we're solving. What do we have to do to get x by itself? Well, in this case, we have to square root both sides. And if we're the ones putting in the square root sign to solve, well, then we identify both possibilities. Kind of quirky. It's a rule in the math world. So understand when you add in a root sign to solve, you need to consider both positive and negative. If the root sign's already there, we just deal with the positive. This will hopefully make sense as we start looking through questions. So keep that in mind because this is really the the square root principle that we did last unit with quadratic equations. We had to square root sometimes to solve, so we had to consider both. There's your square root principle, and that will be used. So we'll have to consider more answers. Make sure you identify restrictions. Make sure you always verify. So with those things in mind, let's solve some quadratic equations. The first one, page 13, root x plus 2, subtract a 5 equals 0. Well, here we go. In order to solve these, the first thing we want to do is, this actually isn't in the notes, I don't believe, but you might want to add it. You want to state restrictions. Because x plus 2 is our radicand, we know that x plus 2 has to be bigger than 0 or equal to 0. So I'm stating the restrictions, identifying what values we could have. Since x plus 2, our radicand, has to be bigger than or equal to 0, if I isolate my x, we know that for this situation, x has to be -2 or bigger. So again, this goes back to whether an answer is extraneous. I'm not saying this is the answer, but to make a point that if we solved this, we did all the work, and we said, oh, x is equal to -7. We did the math right. If x equaled -7, well, -7 isn't bigger or equal to -2. It's smaller. So in this case, x minus equal to -7 would be considered an extraneous answer, because the restrictions telling us we need only x values bigger than or equal to -2. If -7 was one of our answers, it would be considered extraneous. So I'm not sure yet what our answer is. I'm just using that to make a point. So we stated the restrictions. Second thing is we want to isolate the radical. We want the radical by itself on one side of the equation. That means the -5. We want to move it away so the radical's by itself. Move the -5, change the other side. We're adding 5, it becomes a +5. Root x plus 2 equals 5. Now we need to actually start to try to do something to get x by itself. Well, to get x by itself, we have to get rid of a root sign, and we have to get rid of a 2. The root sign has to be eliminated first. There's your step 3. How do you get rid of a root sign? Well, this goes back to the work we did with multiplying. Anytime I have a radical and I multiply it by itself, a radical multiplied by itself leaves me with the radicand. So anytime I have something, x plus 7, or in this case, let's use x plus 2 as a root, and I multiply it by the same thing, something as a radical times itself, all we're left with is the radicand. So this squaring the radical gets rid of our root sign. But remember, equations, whatever you do to one side, you have to do to the other. So we now have x plus 2 is equal to 25. At that point, we now solve for the variable. Solving for the variable here, this is nice and easy. How do we get x by itself? Subtract 2 from both sides, and x is equal to 23. There's our solution. Or we think it's our solution, because our last step is to always verify and make sure that our solution is not an extraneous solution. So I need to verify I have the original question. A verification always should be done with the original question, because if you made an error somewhere down here, you might use something, maybe you're verifying, but you're verifying with the wrong thing. So always verify with the original. We have root x plus 2, but we now think x is 23. So we have root 23 plus 2, subtract 5 equal to 0. Verify, remember, isn't about solving or isolating. It's just about doing the math on the left and the right side separate. We're hoping to get a 0 because that's what's on our right side. Well, the square root of 23 plus 2 is the square root of 25 minus 5. Square root of 25 is 5. And again, the root sign was already there. So it's just the 5. This root sign was there. I don't need to worry about positive, negative 5 because the root sign was there. So we have 5 minus 5. That equals 0. Well, look at that. Left side equals right side. That puts a smile on my face because x is equal to 23. So that's a pretty straightforward one. Solving was very simple because all we had to do was get rid of a plus 2. They're going to get a little trickier. Here's where it gets a little trickier. If we go to page 14, we have root 3x plus 3 minus x equals 1. Here we go. Step number 1, state your restrictions. So our restrictions in this case, we know that our radicand, 3x plus 3, has to be greater than or equal to 0. We have to have a positive or a 0 for the radicand. So if I subtract 3, 3x is greater than or equal to negative 3. I divide by 3, and x is greater than or equal to negative 1. So we know that whatever we solve for, if our x isn't greater than or equal to negative 1, it'll be an extraneous solution. So there's step 1. Step 2, isolate the radical. X has to go to the other side. So we have root 3x plus 3 equal to, if I move the x over, it becomes a positive x plus the 1 that's already there. There we go. Radical's isolated. Square the radical to eliminate the root sign. So I just get to square this whole thing. If I'm going to square this whole thing, a radical times itself is just the radicand. So we've eliminated it. But I have to make sure I square the other side to balance it. Be careful here. Oh, how many times have I talked about this? X plus 1 squared is x plus 1 times x plus 1. Make sure you FOIL that. So x plus 1 times x plus 1, if you do all the FOIL steps, x squared plus 2x plus 1. There's the foiling of the x plus 1 squared. Well, we've eliminated the root sign, so now we're on to step 4. We want to solve for the variable. Wow, solving for the variable. Last time I didn't make mention of it, but now the reason we do this unit after the last unit, we have an x squared. We now have a quadratic equation. What are the two most effective ways of solving a quadratic equation? Well, factoring or the quadratic formula. I'm not saying everything, but you will find the majority of this can be done with factoring. Using the quad formula isn't efficient. If you can factor, it's going to help immensely. But in order to solve a quadratic, first of all, remember everything has to equal 0. So I need to move all of this stuff over to the other side. So 0 will equal, I still have an x squared. The 3x went over, so it becomes a negative 3x, which leaves me with a negative 1x. The 3 comes over, which is going to become a negative 3. 1 minus the 3 will be a negative 2. So there's the quadratic that I could now solve. You could plug into the quadratic formula x equals negative b plus or minus the square root of b squared minus 4ac over 2a. Or you could identify, this is a simple trinomial. And a simple trinomial, what multiplies to negative 2 but adds to negative 1? Well, if you're good with your factoring, multiply to negative 2 but add to negative 1 is a negative 2 and a positive 1. Negative 2 times 1 is negative 2. Negative 2 plus 1 is a negative 1. There's my factored form. So what does this tell me? It tells me that x is equal to positive 2 if that were equal to 0, or negative 1 if that were equal to 0. So there's the two possible answers, 2 or negative 1. Now, double check. We have to verify. Well, first thing I'm going to verify is I'm going to look at my restriction. Our x values have to be larger than or equal to negative 1. Larger than negative 1, equal to negative 1, they're both okay with those constraints. Now, I could also do a verification. I'm just going to go to a new page because I have a little bit more space to do that. So our initial question was 3x plus 3 minus x equals 1, and we think that one possibility is x equals 2. So here we go. Square root 3 times 2 plus 3 minus 2 equals 1. So I put x equal to 2 in. We have 3 times 2 is 6 plus 3. We have root 9 minus 2. Root 9 is 3 minus 2. 1 equals 1. Left side equals right side. Again, puts a smile on my face because I know that x equals 2 is correct. Second possibility is we thought that x was equal to negative 1. So let's verify into that one as well. Substituting in 3 times negative 1 plus 3, subtract x, which is subtract a negative 1, equals 1. So to verify, 3 times negative 1 is negative 3. Negative 3 plus 3, we have root 0. Minus negative 1 is really plus 1. 0 plus 1 is 1. That right side is 1. So again, left side equals right side. X equals negative 1 is correct. So in this case, when I verified, yes, x is 2 or negative 1 because it meets all of the verifications. There's your solving. Let's take a look at another one. Give this one a try maybe on your own. Same kind of question, not a lot different than what we just did. Give it a try. All right, so first thing, restrictions. We know that 2x minus 1 has to be greater than or equal to 0. If I isolate the x, we know that x has to be greater than or equal to 1/2. So if we get an answer smaller than 1/2, it's going to be an extraneous solution. So restrictions taken care of. Isolate the radical. Look at that. It's already been done for us. Nice. Don't have to do anything there. Square the radical. Square it. That leaves us with 2x minus 1. Square the other side. FOIL. X minus 2 squared. Remember, you have to do FOIL there. So we have x squared minus 4x plus 4. So what do we have to do now? We squared the radical. Well, now we're solving for the variable. Again, we see that we have an x squared, so we have a quadratic equation that needs to be solved. First thing is always get your quadratic equation equal to 0. Moving the 2x over, so it's a negative 2x. Moving the negative 1 over, so it's a positive 1. 0 is equal to x squared minus 6x plus 5. Finish off the solving. Well, quad formula, or look at that, another nice, simple trinomial. What is going to multiply to 5 but add to negative 6? Well, multiply to 5, add to negative 6. What about negative 1, negative 5? Negative 1 times negative 5 is a positive 5. Negative 1 plus negative 5 is your negative 6. So our factored form is x minus 1 times x minus 5, which means in order for this to be 0, x is 1. In order for that to be 0, x would have to be 5. There's the two possibilities. But we have to, as always, verify to make sure there isn't an extraneous solution. First thing, restrictions told us that x had to be greater than or equal to a half. It's definitely greater than a half, definitely greater than a half, so we're okay there. But now we need to do a verification. What's important to understand is when you verify, this verification, you don't necessarily have to show a big, long process with it. If you get an extraneous solution, that's what you should show. But you don't have to do a whole big, long, I'm just showing you the process to show you what a verification, how you can do it. So how I would verify and expect it, well, here's the original question. We have the square root of 2 times x minus 1 should equal x minus 2. Because that's what our original question was, and we always verify in the original question. So that's what I want to verify in, and that's what I've done. Root of 2 times x, which we think is 1, subtract 1 equals x, which is 1 minus 2. So solve each side separate. 2 times 1 is 2. 2 minus 1, we have the square root of 1 here, which is 1. I also, in this case, have the fact that I have a 1 minus 2, which is negative 1. So in this case, does 1 equal negative 1? Left side does not equal the right side, so no. X equal to 1 is extraneous. It is not a solution because left side doesn't equal right side. Let's try the other answer, which we thought was 5. Square root 2 times 5 minus 1 should equal 5 minus 2. 2 times 5 is 10. 10 minus 1 is 9. So we have root 9, which is a 3. Over on this side, 5 minus 2 is 3. Look at that. Left side equals right side. So what does that tell us? That tells us that x equal to 5 is correct. X equal to 1, extraneous, isn't acceptable, but x does equal 5. X equal to 1 is extraneous. Solving. Understanding extraneous solutions. From there, we go to question 5. Question 5 is about as big and ugly as you're going to see because we have two radical signs. So, first thing, restrictions. Well, to start with, the first one, we know that x has to be greater than or equal to 0. Our radicand has to be 0 or bigger, so x has to be greater than or equal to 0. And also, we know that x plus 16, because it's a second radicand, has to be greater than or equal to 0. If I subtract 16 from both sides, x must be greater than or equal to negative 16. So we have to make sure that our x values work for both restrictions. Now we isolate the radical. Well, here it's different because we have two radicals. We can't isolate them. We want to put a radical on each side of the equal sign. Now, because we have an 8, whenever we have to put a radical with a value, my suggestion is always move the radical that's less involved. Root x is way nicer to work with than an x plus 16. So I'm going to be left with x plus 16, and over on this side, I'll be left with 8 minus root x. Well, we've isolated the radical on each side, so now we square the radical, square this side to get x plus 16, but I need to square this side. 8 minus root x. That's going to be a little bit of scratch work off to the side because it is not straightforward. 8 minus root x squared requires FOIL, so we're going to have 64, negative 8 root x, another negative 8 root x, and a negative root x times a negative root x. Root x times root x is just x. Negative times negative is a positive. So on this side, I'm going to have 64. Negative 8 root x and negative 8 root x is negative 16 root x. Combine those like radicals, plus an x. So I have squared to get rid of the radical sign, and I squared the other side, which was a little bit ugly, but I still have a radical. So what do we have to do? We have to isolate the radical a second time for this question. Involves a little bit of work. So I am going to take my 16 root x and I'm going to move it to this side so it's a positive 16 root x, which means I'm going to be left with, I'm going to move the x over, which will make it a negative x, cancels out. I'm going to move the 16 over, which will make it a negative 16, and 64 minus 16 leaves me with, what is that? Oh, got to do the calculation. 64 minus 16. 40 minus 6 is 8. 5 minus 1 is 4. I get a 48. So I have a 48, and that's it at this point. I just end up with 16 root x equal to 48. Because the 16 root x came over, there it is. The x moved over and canceled out, and then I was just left with my 48. So now I have to square the radical a second time. So I need to square my radical, and that means I need to square the other side as well. Nice thing is here there's no FOIL, but we have to be careful. 16 root x times 16 root x. 16 times 16 is 256, and root x times root x just leaves us with the x. So we have 256x equal to, and we just have to go 48 squared, which is 2,304. And at this point, now we can solve for the variable because we've finally gotten rid of the radical. Is it a quad equation? It's not. How do we get x by itself? Nice and easy. Just divide by a 256. And x works out to be 9. So, x works out to be 9. Have to always check. First of all, 9, is it bigger than or equal to 0? Yes. 9, is it bigger than or equal to negative 16? Absolutely. So it meets the restrictions, but we always have to verify. So I substitute into, as always, the original equation, but now I can put in 9 for x. Root 9 plus root 9 plus 16, we're saying it should be equal to 8. Root 9 is 3. 9 plus 16 is 25. So root 25 is 5. 3 plus 5 is 8. Right side is 8. Left side equals right side. Once again, a smile on my face. Why? Because x equals 9 is correct. Solving radical equations. The big thing is the fact that we have to isolate the radical, but then square it to eliminate the radical sign. And then it's just solving that we've done already. So that's algebraically. What's nice is, again, our calculator will do this work for us. Please be careful. Anytime a question says solve algebraically, you cannot solve graphically. But anytime a question says solve algebraically and you get an answer, man, solving graphically as a verification is a great thing to do. So here we go. How do we solve graphically? Not anything new. First things, we always have to have everything to one side, so it has to equal 0. Now, this is on page 15, but I'm going to solve graphically the question we just did. We just solved this, and we figured out that x should equal 9. So let's see if we can get that graphically. Everything has to be on one side, as always, because we're going to plug into our y equals on the calculator. So I'm going to move the 8 over. So we're going to have to substitute or plug into our calculator root x plus root x plus 16, subtract 8 equals 0. So this is going to be substituted into our calculator, plugged into the calculator. Sorry, the whole thing will be plugged into the calculator, and we'll go from there. So pull up the calculator. We have root x. Make sure that you don't keep punching in, because if you keep plugging in, you're going to be under the root sign. You don't want to be. So when you hit and you want the root of something, oh, that didn't work. I just want to clear everything. Second, to get the root sign, we want root x. Use the cursor to move over that highlighted red button. You can see you're now out of the radical. So root x plus, we want to add that to the root of x plus 16. Leave the radical. Oh, look at me, McDonald. Wake up, man. Here we go. One more time. Root x, leave it. When you leave it, now you have to make sure we're going to add to that the root of x plus 16, leave the radical sign, and because we moved everything to one side, we have subtract 8. That's what we're going to plug in, but again, we need to plug it into y equals. Oh, got to be honest with you. It is like 2:45 on a Friday right now. That's my excuse. Honest, that's what time it is. This is why I'm struggling a bit. Here we go. Now that we're in y equals, now we can go root x, leave the radical, add x plus 16, leave the radical, subtract the 8 so that everything's on the one side, which we had to do. Now we're going to graph that. Now again, we might have to change our window settings. When we solve for x's, we're looking for the x-intercepts. I can't see the x-intercept real well. I'm just going to change my window settings so I can see more to the right. That's my x max. I'll just change that up to 20. Graph it again. There. Now I can nicely see what it is. Now in this one, it's nice. The way it's laid out, I can see where it's crossing at. But do I know for sure? So very quickly, how do we find our x-intercept? We've done this. Second trace. We want the 0 values, number 2. And now we want to scroll so we're on the left side of the x-intercept. Hit enter. We want to be on the right side of the x-intercept. Hit enter. Please guess the answer. And the answer, x is 9 for y0, so the x value is 9. There you go. We know that x equals 9. We can solve it graphically, which we did, and that meets the one that we solved algebraically. One more quickly. Hopefully this one won't take me as long to get through. But big and ugly, a lot of times you're going to be asked probably to solve graphically if you have 2 radicals. A lot of times that's the time you do graphically because it's a lot of work algebraically. But remember, the first thing is we need to get everything to one side. So because the root x plus 5 is all I have on this side, I'm going to move it over. That'll give me a 0. I have a root 2x plus 7 there now. I have subtract 1. So when I move a positive root x plus 5, it will become negative root x plus 5. The sign in front will change anytime I move something across the equal sign. So this is what I now need to substitute into y equals, graph it, and look for the intercepts. So here I go. Let's see how I make out with this one. Maybe it won't take as long. Y equals. Clear that. Make sure you're in y equals. That's probably best. So here we go. I had root 2x plus 7. Leave the radical sign. Subtract 1. And then I subtracted the radical that I moved across the equal sign, x plus 5. Leave the radical sign. So root 2x plus 7, subtract 1, subtract root x plus 5. I want to graph it. I have 1 point of intersection. Not as easy to see there. So this is now why the second trace will become important. Second trace, I want the 0. I want to be to the left of the intersection point. Now I want to be to the right of the intersection point. Please guess the answer. 5.472, blah, blah, blah. So we can estimate that x rounded to the tens place would be 5 and 5/10. So in this case, x equals 5 and 5/10, 1 intersection point, so only one solution. There's your assignment, solving radical equations. Couple questions, it builds. Pretty easy, a little harder, makes you think. So it sort of goes up in the complexity. Give them a try, make sure you understand, have some fun with it. Have a great day.